Good morning, everyone. Welcome to the course titled Artificial Intelligence in Industrial Management Engineering as part of the NPTEL MOOCs course content, which is created from IIT Kanpur. I am Professor Deepa Philip. I am a faculty member of IIT Kanpur, and along with me, Dr. Prabal Pratap Singh is co-teaching this course. And we are in the current week, we are going through the concepts of logic, expert systems, and why expert systems are important, and how knowledge representation helps us to actually take rule-based decisions and conclusions, testing a hypothesis, etc. We already seen that, and in that time period, we have seen quite a lot, or we have represented many a times the word called logic. So, in today's lecture, if you look into it, we are going to talk about the concept of what we call as logic. So, the first question in this is, what is logic? Okay. Let us say logic was originally just the study of what distinguishes sound argument from unsound argument. Okay. Been there and worked on for a long time period, okay, like centuries and all, into a powerful and rigorous system. Okay. It has been there, the system has been. So, if you think about it, it is originally just a study of distinguishing sound argument against unsound argument. Okay. And it is now, it has been worked on. Okay. It existed there for a long period of time, and people continue to work on it, and it resulted into a powerful and rigorous system. Okay. So, this rigorous systems allows for the discovery of true statements. Okay. So, it allows for the discovery of true statements, provided that other given statements are also known to be true. So, that is the logic behind it. If you, given that the other given statements, if they are also known to be true, then from there you can actually discover the true statement. Okay. So, that is the concept of logic. Now, the next question is, why is logic important for us? Okay. So, we can say AI viewpoint, okay, viewpoint, and IE viewpoint also. From both the viewpoints, logic is valuable because, okay, it is valuable because provides a language for knowledge representation. So, logic provides a language for knowledge representation with well defined, non-ambiguous semantics. Okay. Semantics is which is a system of meaning. Okay. So, what we are saying, it provides a language for representing knowledge or knowledge representation. What is the advantage of it? This language is well defined, it is non-ambiguous, and it has semantics. It has a system of meanings. Okay. Now, the next thing is it provides well defined proof theory. Okay. So, what is it? It is reliable techniques in formal logic to establish that an argument, okay, is sound. Okay. It's a set of reliable techniques, okay, in formal logic that has the capability that can help you in establishing that an argument is sound. Okay. So, an argument is sound. Okay. So, let us see what is an argument in this regard. Okay. We can think about it as set of deductions from statements that are known to be true. So, you have a set of statements that are known to be true, or you have a bunch of statements that are known to be true. From there, you make a set of deductions. Okay. That deductions form an argument, right. So, this makes logic a gold standard. Okay. So, that is the reason why people consider logic as a gold standard, because it is very well defined, non-ambiguous aspect. Okay. So, then the other thing is other knowledge representations can be evaluated according to whether they produce the same results as formal logic. The same results as formal logic. Okay. So, it allows you to evaluate other knowledge representations. You can look into other knowledge representations and see whether they produce the same results as that of the formal logic. Okay. So, which means you can say if they produce different results, okay, you can say something is wrong with them. Okay. So, that is the logic. This is the basic aspects of why the logic is important and what are the benefits of logic. Then languages based on formal logic. Okay. Just have to give you some basic ideas of this. Various forms of logic. Okay. Simplest is propositional calculus. Okay, known as sentence logic. Okay, propositional calculus is simple one. Okay, then most commonly used in AI. Most commonly used in AI is first order predicate calculus. Okay. Also known as first order predicate logic. Okay. That is the second one, the most commonly used. We will say propositional calculus is built out of simple statements. Simple statements called propositions. Okay. So, they are made of simple statements, and the simple statements are known as propositions. Now, the next thing is propositions are either true or false. They are binary, they are either true or false. Okay. Propositions are either true or false all the time. So, let us look at an example. Okay. Delhi is a city. Okay. This is a proposition. Okay. Ice is cold. Okay. Is another proposition. So, Delhi is a city, it is true. Ice is cold, that is true. If I say ice is hot, that is false. Okay. So, I will say let us do it this way. Ice is, if I say it is hot, this is a true proposition, this is a false proposition. All right. So, we know the simple propositional calculus and the first order predicate logic are the two common ones. So, just look a little bit into the propositional calculus at this point, okay, very quickly. We will not spend too much time here. So, we also know that propositional calculus is built of simple statements. So, the simple statements are joined together, to form more complex statements, by what you call as propositional calculus. Okay. So, or another way to say it as standard symbols. So, the standard symbols, so what we do is we can create more complex statements by combining these or joining these statements. Okay. And what does the standard symbols will do? They express simple ideas like and, or, not, etc. Okay. So, major standard symbols. Which are the major standard symbols as part of this? So, the first one is this shape, the V. This stands for and. Okay. The next one is the reverse of this, stands for or. The third one, this one, stands for not. Okay. Then stands for if then. Okay. And then stands for if and only if. Okay. So, these 5 basic major symbols. So, and, or, not, if, then, if and only if. Okay. So, how do propositional calculus can be used to represent logic? Okay. Let us take a look into it. Example statement written in propositional calculus. In propositional calculus. Okay. So, we have couple things. Okay. R stands for it is raining. Okay. G stands for I have got an umbrella. Okay. Then W stands for I will get wet. Okay. If these things, then I am writing a statement here which is more like R not G. Okay. This is a propositional calculus statement which I have written R, G, W and then symbols in between. Okay. This will help you to, this implies that if it is raining and I have not got an umbrella, okay, then I will get wet. Okay. So, how do you tally those ones, okay, or how do you connect them? Okay. This is the and, okay. Okay. So, this is the not, okay, and if you remember this symbol, it is this if then, right. So, this is the then and if. Okay. So, the statements, okay, this connects to R, it is raining, okay, and I have got an umbrella, this is actually not G. Okay. I have not got an umbrella, G is I have got an umbrella, this is not G. Okay. Then this is W. Okay. So, that is how you can think about how propositional calculus can be used. Now, let us talk about maybe an example of what we call as predicate calculus, or first we talk about predicate calculus a little bit. Predicate calculus can make statements about objects, okay, and properties of the objects. And relations between objects. It can make statements about the about objects, properties of the objects and relationship between the objects. Okay. Propositional calculus can make statements about relationships. Okay. So, then we will say it contains predicates. Okay. Statements like A of S, okay, or B of S T, something like this. Okay. So, what does this means? Okay. This implies that S has the property A, okay, B of S T implies, okay, that S and T are connected by the relationship B, okay, something like this. Okay. So, let us work a simple example which will make your life easy and you can probably understand that quickly. So, statement written in predicate calculus. I am hoping that you guys will be able to read more contents on this. C stands for the cat. Okay. Next one is M stands for the mat. Okay. Then S stands for sits on. Okay. Now B stands for black. Okay. Then F stands for fat. Okay. H stands for happy. Okay. If these things are known, if this is given, then look at the statement F C in B C and S C comma M, then H C. Okay. If I write this, I can say that if the fat black cat sits on the mat, then it is happy. Okay. So, CHC means, if you remember the previous one, if you look into this, A of S means S is a property of A. So, an example of this is, if I write this, HC is, H is the property of C. So, which implies C is cat, H is happy. So, HC is happy cat. Okay. So, that is how you can think about the predicate calculus example. Okay. So, you can come up with other things as well. All right. So, there is also the same way we have used these standard symbols in propositional calculus. Predicate calculus also have what we call as quantifiers. Okay. So, we will say also has the same logical connectives as propositional calculus. They have the same as that, same logical connectors. Okay. Which were the logical connectors which we have seen earlier? The logical connectors were and, or, not, if then, if and only if. Okay. The same logical connectors is available here. Okay. predicate calculus have two quantifiers. Okay. The first one is something like this, meaning for all. Okay. That is the first one. The second one is it's an reverse E, meaning there exists. Okay. So, these are the two quantifiers of predicate calculus. Okay. So, now if that is so, let us look at an example, predicate calculus example, okay, just to demonstrate the point and get you introduced to this concept. Okay. So, example statement. Okay. This is how you can capture and represent knowledge. That's it. Okay. Let us say D stands for is a day. Okay. And then P stands for is a person. Okay. Then MO stands for is mugged on. MI stands for is mugged in. Okay. Then let us say S stands for Shanghai. Okay. Then X stands for some unspecified day. Okay. Y stands for some unspecified person. Okay. So, if this is the case, okay, we can say that for every x, okay, or for all x, we say d of x p y and m o y x m I y s. Okay. It is a crazy statement, looks like weird. So, we can say that what happens is that it expresses the idea someone is mugged in. Someone is mugged in Shanghai every day. Okay. So, this is, you can see how this translates to that, okay, from the thought process. With that, we come to the conclusion of this lecture, and hopefully this helps you to find out or this helps you to understand the concepts of predicate calculus and propositional calculus, how logic is important, and connect with the knowledge logic and why logic is considered as a gold standard and why it finds a lot of applications in the industrial engineering domain. So, thank you for your patient hearing. We will be back with more content later down the road. Thank you.